Hello and welcome to the course overview of Engineering Electromagnetics 1, EC2105 to be offered for 2021 spring semester. I am an instructor of this course, Youngmin Song, in the School of Electrical Engineering and Computer Science. I'm going to start with this video clip introducing how does Face ID work. In your iPhone, you have these Face ID options for authentication, and your smartphone have a dot projector, and this dot projector illuminate light patterns, and some of the reflected light from your face are captured by this IR camera. And then with some kind of a reconstruction of the captured images, you can generate 3D shapes of your face. It seems like really simple, but if you want to go into details, or if you want to develop such kind of interesting functions, then you should learn some of the fundamentals. So for example, if you have an interest in how to generate IR dot patterns, or how to develop compact IR cameras with a high efficiency or integration with display technologies, then you should learn about optical technologies, which include the operating principles of cameras or LEDs and so on. And before that, you should take the class on semiconductor materials and devices to understand the operating principles of semiconductors. And also, as a prerequisite, you should take two important fundamental courses. First one is a circuit theory, and another one is a engineering electromagnetics to understand electromagnetic waves and the light matter interactions. This is kind of a course tree, and this engineering electromagnetics course is starting point of the EE classes. So without this class, it's really hard to understand key concepts of these technologies. For more details, if you have a question on how many percentages of the light will be reflected from your face, then you should know reflection characteristics of the electromagnetic waves between air and your skin. So in this class, you will learn about these characteristics in chapter 8 in your textbook. And in order to understand these wave characteristics, you should learn about the boundary conditions at the interface for the electric field and the magnetic field, together with some kind of a vector analysis. And definitely, those vector analysis could be very useful for learning many other engineering courses. And I'd like to highlight that the usefulness of this course is not limited to these examples. For example, if you have a question on which wavelengths of light we need to use for the case of the Face ID, then the answer is around the 5.9 micrometer. That is a near-infrared electromagnetic wave. On the other hand, when you look at anywhere in our daily life, you could find many other electromagnetic waves, such as a display, thermal cameras, UV lamp, microwave ovens, lidars, and many others. It means that the comprehensive understanding of the electromagnetic waves could be very useful to understand the world itself. And this is the last slide, and this figure is a course tree for electrical engineering. And you can see here, our course is kind of a starting point for the all of the EE students. And if you have a strong background on the electromagnetics, then it means that you will be able to have a happier college life. Alright, so this is the end of the introduction, and I hope you find this course is very interesting to you. Thank you very much for your attention, and see you soon. Bye.